Hey there everyone, and welcome to another lecture of this Catia series. In this lecture we are going to see one exercise regarding this DMU simulation, and here we are going to see how we can just simulate the single cylinder engine that we have assembled in the previous lectures when we have seen the assembly. So let's just start our Catia and let's just see how we can just simulate these things. And during this whole exercise, we are going to see a lot of terms in action, like the assembly constraint conversion. We are also going to see how we can just create the manual joints and all. So let's just start our Catia and let's just start this. So for that, I am already inside the DMU kinematics, but we want to go in the assembly first. So we are going to click on the assembly. Now you can see that the whole assembly interface is open. So we are going to just import, or you can see that we are going to just go for the open over here. And then from the folder, and this folder is provided to you, so you can just practice all the designs that is present over here. So from here we are going inside this tutorial one, and from here I have already just created one product. Okay, so I think it is creating a problem to open. Yes, now it is open. So you can find that I have just already assembled this whole engine assembly. And in the previous lectures, I have also shown you how we have assembled this whole things. So here you can find that I have already created one mechanism, and it is having one revolute joint, but we don't want this mechanism right now. So we are going to delete the whole thing. And since we have created all the constraints, you can find the constraints over here, and you can see that some of the constraints are not updated over here. So just click on the update so that all the constraints are getting updated. So here you will find that some of the problems is representing over here. So these constraints, it will ask you to delete or deactivate these constraints. So we are going to just delete this whole thing that are not being created, like this too. So you can see that now we have the whole assembly ready, and I think this much of constraints is enough. Okay, so here it is showing you the two fixed points. So we have to show some modifications over here as well. So we are going for the fixed together over here. Let's just say which is the fixed first. This base is fixed. So I'm going for the fixed together constraints, and I'm going to select this two figure over here, and I'm going for the OK. You can find that we have the fixed together. Basically this fixed together, what it will going to do, it will going to just attach the two parts together, creating it to be a single part. So here we have the two parts over here, but it is visualizing us the same part as we have just used the fixed together constraint over here. So now you can see that we have the constraints. So let's just update our project again, and then I am going for the simulation. So we are going for the start, and from here we are going for the digital mockup and then the DMU kinematics. So now you can find that we are inside the kinematics over here, and now what we are going to do, we are going to just create the conversion. Since there is a lot of joints that we have to create, so creating all the joints manually is pretty difficult, so we are going to just convert the whole constraint. So just click on this assembly constraint conversion, and then it will ask you to create the mechanism. So here just go for the new mechanism, and just let's name it as, let's say, simulation, or let's just name it as engine. That will be better, I think. So now you can find that we have named it as engine, and we are going to auto create it, since we have to create the whole thing automatically. So just click on this auto create, and you can see that it will automatically going to create some pairs, and you will find that we have degree of freedom 2 over here. So that doesn't required by us, we require the degree of freedom as 1. So we have to just inspect our joints where we are getting error. So the first one is the rigid joint over here, that is done with the help of this fixed together that I have created later, and that was between these two parts. So then we have the revolute joint between these two bodies. You can find that the revolute joint is between this offset and this one. So this revolute joint, what is it is doing, it is just rotating this whole crankshaft along this whole body. Then we have the cylindrical joint over here, and this cylindrical joint is between the piston and this head, and that is giving piston a translation motion, since as I have told you that the cylindrical motion can create the translation or the rotation motion, or either it can create both of the motions. So here the cylindrical joint is used for creating the translation motion of the piston between the block and this piston. So that is also a good joint. Then we are talking about this cylindrical, which is cylindrical 4, and that is between this part. So here it is showing some error because here we don't want a cylindrical joint. Since this shaft is rotating, so this whole crankshaft, let's just hide this whole thing, that will understand you better. So you can find that this section, this is the section that is showing up the cylindrical joint over here, and we don't require a cylindrical joint over here. We require the revolute joint. So this cylindrical joint can be replaced by the revolute joint. So let's just delete this whole cylindrical joint, since it has automatically created the cylindrical joint over here. That's due to the lack of the joint or the constraint that we have provided. So we have to just fix this out, and we have to create the manual joint over here. So just double delete whole things. And why we are deleting the cylindrical joint? Since because it is showing only the coincident option, so that's why the piston is going to be slide over here. So that we don't want. We want this piston to be fixed on its place, just it rotates along this crankshaft. So just delete whole cylindrical joint over here. And then what we are going to do, in the place of the cylindrical joint, we are going to create the revolute joint, and that manually we are going to create. So the lines that we have to select is this one first, and then this one. So we have selected the connecting rod line, and then we have selected the crankshaft line. Now for the plane, we are going to select this one as our first plane, and for the second plane, we are going to select the body plane, which is this one, and just press OK. So you can see that when I have just changed the joint over here, I have just replaced it with revolute joint. You can find that ultimately we have got the degree of freedom 1. So I think that was the major problem that was arising over here, that is making it to be a degree of freedom 2. So once we have just repaired those things, you can see that we have got the correct degree of freedom over here. And one mistake over here is that we have created a revolute joint between these two sections. So it has just stuck it over here. You can find that the space between them is lost. So I can just double click over the 0 again, and I can just put a new space. That doesn't matter. And you can just update your project. This is the update. Okay, so I think this 15 is very much. Just make it as 5. That will be better. Believe me, I don't know the exact value, so I'm just guessing it out the value. Let's just make it as 15 again. So now you can see that we have the degree of freedom still 1, so that can be rotated. So once we have created all the things, then we have to just make this degree of freedom as 1 again. So for that, I'm going to just click on this revolute joint and just power it out. So I'm going to make it as angle driven over here. And once we have just clicked on this angle driven, you can see that it will show you the message that we are waiting for, and that is the mechanism can be simulated. So once we have done that, you can just press OK. And now with the help of the speed and acceleration only, I can just rotate this body, and we can find that if it's working fine or not. So yes, it's completely working fine. Then I'm going to bring this whole body back. So once we have created this, you can see that we can just go for the simulation that we have created, or you can just select the laws over here. It's totally up to you. You can just provide the laws. I have just double click over this revolute and just provided the angle driven over here. Since we have powered the angular value, so we are going to provide the value or the revolute angle or the laws to this command, which is due to this revolute joint over here. Or you can just directly go for the simulation over here, or you can just select this engine to be simulated and just press OK. And we will find this simulation in this DMU generics animation. So Once we have started the simulation, you can see that the simulation box will going to be open, and we have to just alter one value and we have to insert it that we have done previously, and then we have to just decrease the steps. And once we play it out, you can find that the engine is perfectly working. You can just increase the speed as well. You can just, okay, so we have to just change the steps, so you can see that the engine is perfectly working now. You can just make it as double over here so that it can continuously move. So you can find that we have finally animated this whole section, and you can find that we have created the joints, and we have used over here the both the things, which is one is the which is the animation constraint conversion, and the another one is that we have created the joint manually. So this is what I'm talking about, and this is all about this exercise 4, and that is that how we can just use the assembly constraint conversion to create the joints. But as you have seen that the assembly create conversion doesn't create the correct joint all the time. So you have to just manually figure it out what is the problem, and then you have to just alter that values and recreate the joint manually, so that you will ultimately get the degree of freedom as 1. So once you have just acquired that degree of freedom, you can just provide the command and the whole rotation can be begun over here. So I think we have just cleared out this whole animation. So I hope you can just again do that whole thing. If you haven't gone for the the assembly video in which we have just assembled this whole part together, so it's just I'm preferring you just go for that video and just watch it before you begin this mechanism. After that, you can just watch this mechanism and you can just create it once by your own. So once you have created the simulation, you can just press OK, and you can see that we have one another section that is a simulation, and that is doesn't have any relation with this loss. You can just click on this simulation, or you can just expand this, and you can find that the whole joints are inside the simulation as well. So just double click over that and you can find that this whole thing is going to be open. Just double click on the simulation section and you can see that you will again get this simulation box, and you can just play it out again by changing the values and all. So I think we have cleared out this section of simulation, and that's all for this lecture, and I'm going to catch up you in the next one.